Next part is content of linear function and their graph. In this video, we will learn about linear function and their graph. Hence, we will learn the definition of linear function, the example of linear function by using free software such as Photomath to explain the solution step by step and have a clear explanation to our audience. And we will also learn real-life application and practice the exercise of linear function and their graph. In the end of this video, conclusion of linear function and their graph will help to improve your understanding for our audience.
What is definition of linear function? A linear function is any function that graphs to a straight line. What this means mathematically is that the function has either one or two variables with no exponent or powers. If the function has more variables, the variable must be constant or non-variable for the function to remain a linear function.
Let's see example 1. Question number 1. fx equal to negative 5x plus 15. Firstly, to find x-intercept, substitute fx equal to 0. Next, move the variable to the left-hand side and change its sign. Then, divide both sides of the equation by 5. So, value for x is 3. This is the graph for this equation. Let's see another example. Question number 2. fx equal to 1 over 3x plus 2. Firstly, to find x-intercept, substitute fx equal to 0. Then, multiply both sides of the equation by 3 to eliminate 1 over 3. Then, move the variable to the left-hand side and change its sign. Next, change the sign on both sides of the equation. So, the value for x is negative 6. This is the graph for this equation. Let's move on to another example. Find x and y-intercept and use them to graph. Question number 1. 1 over 4x minus 1 over 3y equal to 3. To find x-intercept, substitute y equal to 0. Any expression that is multiplied by 0 equal to 0. When adding or subtracting 0, the quantity does not change. Multiply both sides of the equation by 4, or you can make 3 divided by 1 over 4. So, the value for x is 12. To find y-intercept, substitute x equal to 0. Solve the equation for y. The value for y is negative 9. This is the graph for this equation.
This is the first question of a real-life application to a linear function. Question 1. Angel's Coffee Shop is selling cups of coffee for Rm2 each. Plot points that represents the total cost if a customer buy 1, 2, 3, or 4 cups of coffee. Determine whether the graph represents a linear function. Write an equation representing the situation. If 1 cup of coffee is purchased, the total cost is Rm2. If 2 cups of coffee are purchased, the total cost is Rm2 times 2, which is equal to Rm4. And so on for 3 cups of coffee, which is Rm6, and 4 cups of coffee, which is Rm8. Plotting the points on a graph using x for the number of cups and y for the total cost in Rm, we have Students should recognize the graph as a linear function since the points line up in a straight line. To write an equation for the function, we know that the total cost is the number of cups of coffee multiplied by Rm2. So we have y equal to 2x, where x is the number of cups of coffee and y is the total cost in Rm. Question 2. The population of a family of stray cats starts with 2 kittens and doubles every month. Plot points representing the total population of the cat family after 1, 2, 3, and 4 months. Thus, the graph represents a linear function. After 1 month, the kittens have doubled once. So since every month the kitten doubles by 2, we times it by 2, which is equal to 4 kittens. After 2 months, the kittens have doubled twice. So we have 2 times 4, which is equal to 8 kittens. And so on for 3 months, which is equal to 16 kittens, and 4 months, which is equal to 32 kittens. Plotting the points on the graph using x for the number of months and y for the number of kittens, we have. Students should recognize that this graph is not a linear function since the points do not line up in a straight line. This is actually an exponential function. A group of young mothers cleans houses for a living and charges Rm20 for an appointment, plus Rm5 per room to be cleaned. Plot points representing the total amounts charged if 1, 2, 3, or 4 rooms are cleaned. Thus, the graph represents a linear function. If it is a linear function, write an equation representing the situation. If 1 room is clean, the total cost is Rm20 plus 1 times Rm5, which is equal to Rm25. If 2 rooms are clean, the total cost is Rm20 plus 2 times Rm5, which is equal to Rm30, and so on for 3 rooms, which is equal to Rm35, and 4 rooms, which is equal to Rm40. Plotting the points on the graph using x for the number of rooms and y for the total cost in Rm, we have. Students should recognize the graph as a linear function since the points line up in a straight line. To write an equation for the function, we know that the total cost is Rm20 plus the number of rooms multiplied by 5. So we have y equals to 20 plus 5x, where x is the number of rooms and y is the total cost in Rm.
From this assignment, we realized that graph and function can be used in many fields. For example, can be used in distance and rate problem, pricing problem, calculating dimension, and more.